All right, we are talking about measures of a discrete probability distribution. So those ways that you can look at the numbers and kind of summarize what's going on in that distribution. So we're talking about a discrete variable that can take on, as I said before, a list of values, and then there are probabilities associated with those x's. So the mean is going to be the same as what we talked about last time, which is the expected value. Just taking those x's, multiplying each one by its probability, and then adding all of those products up. And then variance, let me put a little line on this so it looks less like an O and more like a sigma. And sigma squared, which is what we call variance, there's two ways to figure that out. One way is the old school way, which is where you take each x, subtract off the mu, and square that, and then multiply by the probability that's associated with that, add that all up. That can get kind of messy. That is not the way I prefer to do it. There is an equivalent way that gets you the same answer every time, and that's the way I use. Instead of doing all of this subtracting from mu, what I do is I take each x and square it, then multiply that by the probability and add it all up, kind of like I did with expected value, and then at the very end I subtract off mu squared. That seems to be a lot less work, especially when you're using a calculator and you've got the numbers typed in already and you've just got to go up a line or two and insert little square symbols after each x, and then just subtract mu squared from the end. So there's two formulas to find the variance. Like I said, I like the second one better, but you're welcome to use either one. Here's an example. Notice again how the probabilities all add up to 1. That's necessary for it to be a good distribution function. So my x can take on values of 0, 1, 2, or 3. So the mean is going to be just the product of all of the columns and add it all up, and that's going to be 1.69. Then to find the variance, I'm going to use the second formula that I gave you, where I square each of the x's and multiply it by the probability, add all of that up, and then subtract my mean squared. And that gets me 0 plus 0.34 plus 1.92 plus 1.17 minus mu squared, which gives me 0.5739. And that would be the variance. So that's how you calculate mean and variance of any discrete distribution of a variable. So if you have any questions, let me know, and I will see you tomorrow.